Did you guys do Venn diagrams last year? No? Yes? So a Venn diagram is a way of representing a sample space and different events in that sample space. So in here in our first example, we draw a big square, and that big square or rectangle represents all things possible, or all events. So there's 100 students in grade 12, 30 of them do archery. So our event here with the circle A is representing those 38 students that do archery. How many people are outside of that circle? Would be 62, because we knew there were 100 students in total. So this is a very simple Venn diagram with one event in it. So the number that do archery is 38, and the number in the sample space is 100. So if you chose a student at random, what's the probability that the student did archery? Well, that's just going to be 38 out of 100. So right now, a lot of the stuff that we're doing, we're just getting used to notation, how different things look. And different definitions. Here's a definition. It's complement. It's not complement in you look nice today. It's spelt a little bit different there with the E in the middle. What it means is something not happening. Now in our IB notation, we're going to be writing it as an A with an apostrophe after that. If you go on to study math in university, sometimes you'll see a complement written with an A with a bar over top of it, so there's some different notations. But what it means is not A, and the probability of not A happening. And this is often, you used it a bit last year in permutations and combinations, because when you counted, sometimes it was easier to count the opposite thing than it was to count the actual thing. So some of your questions were, there's 10 people sitting in a row, but 2 people can't sit beside each other because that'll cause a problem. So your best way of counting that was you actually grouped them together and counted all the ways that they were together, and then subtracted that from the total to find out how many were left. So the complement is a very helpful thing. And so if you wanted to figure out how many people were not in archery, well, there was 62 people left out of the 100 that didn't do archery. And how did we figure out that number 62? We took the total, which was 100, and we subtracted the 38. The complement and the event, when they're added together, will always equal 100%. Because the chances of it raining and not raining tomorrow is 100%. Both of those things together, when you add them together, will be 100%. But if we take that and rearrange it, we get this idea that the probability of A not happening is just 1 minus the probability of A happening. So if there's a 38% chance that someone does archery, we just do 100 minus 38. And that's what this 1 is. This 1 is really 100%, right? 100% minus 38%. In decimals, it would be 1 minus 0.38, would leave us with 0.62, the percentage that they're not in archery. Now sometimes you might have 2 events in a sample space. So I'm going to do a survey of this class. I want to know how many people like spaghetti, I also want to know how many people like pizza. Okay? If I did that in this class, there might be some people in this class that like spaghetti and pizza. They would be in this intersection point in between. So if event A was spaghetti and event B was pizza, this part in the middle, I'm sorry, I shouldn't use food examples at lunch, right? Oh, okay. Cats and dogs. There we go. Some people like cats and dogs. Some people only like dogs. That was close, eh? And some people only like cats. And there are some people that don't like cats or dogs. So this Venn diagram has an intersection, and that intersection is where you like both of them. This part here, that section is you like cats, but you don't like dogs. Because the whole circle here would be liking cats. And if the whole circle B here is liking dogs, this section in here would be those people that like only dogs but not cats. And all around the outside are people that don't like either. So if I did this survey in this class, I might have, you guys look like animal lovers, 15 people like cats and dogs. Because of allergies, there is 6 people that like only dogs. And because of a childhood experience, there are 2 people that like only cats. And a really serious childhood experience, if you add those up, that adds up to 23. I said there's 26 people in class. There are 3 people that don't like either of them. And that's what that Venn diagram would look like. But we write the intersection of those 2 places with this notation. A intersection B. And it means, in words, A and B. We're looking for someone who likes A and they like B. So one way that I remember this notation is I think of the word and I think this kind of looks like an A. Sometimes I think it looks like an A too much and I actually accidentally draw the line in between it, and then I go, oh, I have to erase that. Another person says it kind of looks like an N, and then if you read this it says and, but, which is really close to and. So maybe that's,
the national anthem.
Again, we have the national anthem twice. That's like 2 classes in a row that they've played the national anthem at lunch. So maybe it looks like and. So maybe that helps you remember that it's this one and that one as far as the language goes. All right, so we're going to make a Venn diagram for this example.
Please stand for the national anthem.
And no. There's 100 students in a gym class. So we're going to draw our rectangle to represent the total. Now we've got archery and badminton. So we're going to draw one circle. I'm going to color code this. This green circle is going to be my archery circle. This red circle is going to be my badminton circle. 38 do archery, 30 play badminton. Of those, 16 do both archery and badminton. Make a Venn diagram to represent this. So we've got our archery and we got our badminton. There is an overlap because there are some people that like both. And what we need to do is we need to put a number in each of the spaces. There's a space that's caused by the overlap, the intersection. There's a space that's only archery, a space that's only badminton, and there are people that don't play archery or badminton. Yes, they do exist. Okay. So we look at our information and we have to decide, is there a number that we could put in right away? Which one? The 16. Because the 16 is both, so we know, and that's where we would start. there's 16 going to be in the middle. Now we might have to do a little bit of mental math. The 38 do archery. I can't write 38 in this space because this space is only archery. But the whole green circle has to be 38. So if 16 people are in the green circle already here, does it make sense that there needs to be another 22 there? No? Oh, man. And if 30 play badminton, how many are left for this part? 14. If we add this all up, we're at 52. And so there's going to be 48 left. So now if we wanted to find the probability that they play both archery and badminton, well, we wouldn't have needed our Venn diagram because it was given in the question to begin with. But we get that 16 out of 100. So part B could have been answered without drawing our Venn diagram. But as we get into more information, like in part C, find the probability that a student at random does not do badminton but does archery. And that can be written as we're looking for the probability where A and not B intersect.
Please stand for the national anthem.
All right, let's pick a color that you can see through. Let's go with this green. Let's make it a little bit transparent. How about there? Nice. And oh, and then you can see the answer already. But that's fine. What I'm looking for here is badminton, but not archery. Oops. Why not? No, I not have a pen. There we go. I want this green. I want it somewhat transparent. I want it thicker. Oh, I want it more transparent. It's gonna. Oh, nice. Can you see that? That looks like a nice. So what we're looking for when we're looking for not badminton but does archery, on our Venn diagram, well, it's almost not dark enough. That would be that section. In our notation here, I can write that section as it's the intersection between the circle of A and not B. So what that's going to look like, take that little bit away, and I'm going to do that same color, same thickness. How's that? That's too dark. Go this one. That's still too dark. There we go. So if I did all of A, that would be this part. And if I did everything that was not B, that would be on the outside of the red. And if my color coding worked out really nice, can you see that this part is a little bit darker? And if you can't, I'll pretend that it was even darker by doing this a couple times. But when you do that and, it's where they intersect. So where I do not B, which is everything outside of the red, and I color in all of A, the part that intersects is that section right there. For the most part, if I was given a word problem like this, I could just decipher that not badminton and archery is this section. That's not bad. But you will have in IB questions, they will give you what I call notation questions, which means they're going to take a question and give you no context and just say, can you figure out what this notation means and do you know how to work with the notation? And that would be if it was listed like this. What is probability of A and not B? So you got to go, okay, look at my diagram. This is A, but this part's in B, so this is the section that's only in A and not B. Or you could think what we did here, shade everything that's not B, shade everything that's A, and find out where the shading happened twice. And then that probability would be 22 out of 100. The union of events, A or B. It's the place where it's either just A, just B, or A or B. Now, this is hard for people because generally when you're having a conversation with somebody and they ask you, do you like cats or dogs? If you like just cats, you'll tell the person, I like just cats. Or if you like just dogs, you'll say, I like just dogs. You probably won't answer that question just with a straight yes. Right? You would give more information. Because it's very hard. So if I ask Aaron just a yes or no question, are you a boy or a girl? Right? It's awkward. Because the answer is yes, but you really want to clarify to the person because it seems like you're giving false information if you just say yes to that. But that is the correct answer. Because when you use the word or, one or the other or both could be true. So, boy and girl maybe not the best example with the overlap, but if we go back to our cats and dogs, liking cats, liking dogs, or liking both, if you like just cats and someone said, do you like cats or dogs, your answer should be yes. If you like cats and dogs, and the person asked, do you like cats or dogs, your answer should be yes. And if you like just dogs, and someone asked you, do you like cats or dogs, your answer should be yes. So the union of events is all three of those sections. As far as the symbol, how I remember that union symbol, so it's the union symbol, and union starts with U, so maybe that is a way that you can remember it. I remember that it's or by pronouncing or, like ur, and then it's A or B, and then it's kind of like a U, I'm not sure. Whatever, sometimes those crazy ways of remembering things stick with you. Sometimes they stick with you way too long. I can still remember the Native American tribes of the Eastern Woodlands from grade 11 because my friend and I made a song. And that song I can still Micmac, Malecite, Algonquin, Creole, Ojibwe, Montagnais, Beoduck. There was one that didn't fit into the song, but they're extinct, so it kind of worked. But yeah, so I still remember that because one of them was Micmac and there's that song. But yeah, so who knows? Maybe sometimes doing crazy things like that helps you remember. So find the probability, going back, that a student does archery or badminton. If we're looking at our Venn diagram from before, we're going to add up all three of those sections. The number one mistake when doing that or question is that people see 38 do archery, 30 do badminton. If I was looking at or, why not just add those together? Why isn't the answer 68? Why is the answer 52? Because 16 do both. So when you count the 38, you've counted those 16 already. And when you count the 30, you count those 16 again. And so you would have counted that twice. Which leads us, here we go, to another example. We got a group of 30 students, 17 play computer games, 10 play board games, and 9 do neither. computer games, board games. So I want you to try and fill out the numbers. So what's the number you can do right away? The 9. There's going to be 9 that do neither. And then you get stuck, right? Because there's no information specific to any one of those 3 things. We know that the whole blue circle is 17. We know that the whole green circle is 10. Any suggestions? Yes. We know that there's going to be 30 in total. So how are we going to use that? Subtract 9 from 30, so there's going to be 21 left in between those. Okay? Does that make sense? So what he's saying is if we take the 17 that play computer games and the 10 that play board games, we know that we've counted some people twice. That, when we add those up, we get 27. But it's supposed to only be 21. So there's been 6 people that have been counted twice because we're over by 6. Okay? And then, once we have that number in the middle,
Please come to the office. Matthew Fennick, please come to the office.
we can fit an 11 so that the blue circle adds up to 17. We can put in a 4 so the green circle adds up to 10. Okay? So that's one way of doing it. Add those 2 circles in the middle, find out how many over you went, and that's how many people you counted twice, which will be in the middle. Anybody use another strategy and who didn't figure out the 6 as their next number? If you have this, here I'll just erase. If we know 9 on the outside, and we know that all of this is 10, how many are left for this part? 11. Does that make sense? So then we could have done this 11 next, and then said, well, this whole circle has to be 17, then get this 6, then get this 4. Or we could have done the whole blue and said, that's 17. 17 and 9 is 26. How many are left for this? Has to be 4 in order to add up to 30. And then once you have the Venn diagram, what's the probability? Plays board games, 10 out of 30. Computer and board games, 6 out of 30. Plays board games but not computer games, would be 4 out of 30. So class is about to end soon. What I want to have you done for next class is example 3 and 4 look at when there are 3 events. See if you can decipher the information so that you can fill in all of the sections and the numbers and then be able to answer the questions. So examples 3 and 4 have that. We'll go over those at the beginning of class on Wednesday. And then there's another exercise at the end there as well.